Hello, STT 315. This is Recitation 6. Our learning objectives are to demonstrate through examples concepts of conditional probability and multiplication rules through the use of probability tree diagrams. Task 1. According to the National Crime Victimization Survey published by the U.S. Department of Justice, about 11.7 million people were victims of identity theft over the past 2 years. This number represents 5% of all persons aged 16 or older in the United States. Of these victims, 53% reported that the identity theft occurred from the unauthorized use of a credit card. Consider a randomly selected person of age 16 or older in the United States. What is the probability that this person was a victim of identity theft? So here, I just wrote down the information that we were given, which is 11.7 million people were victims of of identity theft over the past 2 years. And this number, 11.7 million, represents 5% of all persons age 16 or older in the United States, or in other words, greater than or equal to 16 years old in the United States. And then we were given this other information. But here, what we're interested in is this value here, which is what is the probability that this person was a victim of identity theft, and this person that we're referring to is that a randomly selected person of age 16 or older. So that was given to us here. So that answer is 5% or 0.05. What is the probability that this person was a victim of identity theft that occurred from the unauthorized use of a credit card? So here we're interested in what is the probability that we have the credit card identity theft. And so we have that equals the probability of identity theft times the probability of the credit card identity theft, given that there was identity theft. So this first value here, we just solved from part A, because we're talking about this person, which was the person of a randomly selected person of age 16 or older. And so we just solved here that it was 0.05, that they were a victim of identity theft. So that's the probability that they were a victim of identity theft. And then we're going to multiply that by the probability that it was credit card identity theft. And if we go here, that we get 53% of 11.7 million was due to unauthorized credit card use. So we're going to multiply 0.05 by 0.53, and that's going to give us 0.0265. Task 2. Geographical analysis presented a study of emergency medical service, EMS, ability to meet the demand for an ambulance. In one example, the researchers presented the following scenario. An ambulance station has one vehicle and two demand locations, A and B. The probability that the ambulance can travel to a location in under 8 minutes is 0.8 for location A and 0.42 for location B. The probability that the ambulance is busy at any point in time is 0.03. Find the probability that EMS can meet the demand for an ambulance at location A. Okay, so my first step is just writing the information that I'm given. So here I'm going to define event M as that the ambulance is available, or in other words, not busy. Event A as that the ambulance can travel to location A in under 8 minutes. And event B is going to be that the ambulance can travel to location B in 8 minutes. And here, these two little lines just mean that I'm repeating whatever is above that. So it's just shorthand, so I don't have to write as much. But so B is stating that ambulance can travel to a location B in under 8 minutes. Okay, and we were also given that probability of A, which is that an ambulance can travel to a location A in 8 minutes, is 0.58, which we were given here. And then for location B is 0.42, which is written here. And then we were given that the probability that an ambulance is busy down here, this last bullet point, is 0.3. So the probability of M, which I defined as that the ambulance is available or not busy, would be 1 minus the probability that it's busy. So that would be 1 minus 0.3, which is 0.7. And here we want to find the probability that the EMS can meet the demand for an ambulance at location A. So here we're just interested in what I've circled in yellow, and I'm going to get back to this overall thing. But here for just part A, we're interested in the probability of A intersect M, which is the probability that the ambulance can travel to location A in under 8 minutes and that the ambulance is available. So since the probability that the ambulance can travel to location A, given that it's available, is equal to 1. So it obviously has to be available in order for it to travel to A. And likewise for B, but we can get into that later. Right now, we're only interested in this first situation. So here we can just, to solve this, multiply probability of A, which is that the ambulance is available, that it can travel to location A in under 8 minutes, times the probability of M, which is that the ambulance is available. So that would be, probability of A is 0.58, and probability of M we calculated as 0.7. So 0.58 times 0.7 is 0.406, which is what we're interested in. Part B is finding the probability that an EMS can meet the demand for an ambulance at location B. So similar to what we just did, but here, however, we would be doing the probability of B intersect M, so that it's available and that it can travel to B in under 8 minutes. So here we have the probability of B is 0.42, and then we calculated this as 0.7, so you multiply those together and you get 0.94. Now, if the question was, what is the probability that EMS can meet the demand overall, then we would have the probability that it can meet the demand for location A and that it can meet the demand for location B. So if we were interested in just if the EMS can meet the demand, then we could add part A and part B together and get 0.7. Okay, task 3. Suppose that 4 inspectors at a film factory are supposed to stamp the expiration date on each package of film at the end of the assembly line. John, who stamps 20% of the packages, fails to stamp the expiration date once in every 200 packages. Tom, who stamps 60% of the packages, fails to stamp the expiration date once in every 100 packages. Jeff, who stamps 15% of the packages, fails to stamp the expiration date once in every 90 packages. And Pat, who stamps 5% of the packages, fails to stamp the expiration date once in every 200 packages. If a customer complains that her package of film does not show the expiration date, what is the probability that it was inspected by John? So, and here's a hint, is to draw a probability tree diagram. And so first, as a little tip, I like kind of color coding so that way I can tell, what information pertains to each person. So here I've color coded that what's highlighted in yellow pertains to John. What's highlighted in this reddish color pertains to Tom. Green is Jeff, and blue is Pat. Just to kind of signal to me and keep that information straight. Okay, so here I'm going to define J as the event that the package is inspected by John. T is that the package is inspected by Tom. H is that the package is inspected by Jeff. P is that the package is inspected by Pat. Event S is that the package is stamped correctly. And event F is that the package is stamped, and I'm forgetting the P here, it should be stamped incorrectly. Okay, so first I'm going to draw tree diagrams for what I know. So here, event J is that the package is inspected by John. So if we go to the information we were given, we have that John stamps 20%, who stamps 20% of the packages. So here we have 20% or 0.2. And of those 20%, we were given that he fails to stamp the expiration date once in every 200 packages. So here for the fail event under John, that would be 1/200 that he fails to stamp correctly. So the remaining probability from if he were to stamp it correctly would be 1 minus 1/200, which is 0.995. And now we're going to do that for each person. So next is Tom. So Tom stamps 60% of the packages. So here, that's 60% of the packages. And of those 60%, he fails to stamp the expiration date once in every 100 packages. So 1/100 is going to be this F event under Tom, and 1 minus 1/100 is 0.99. And here for event H, that pertains to Jeff. So if we go here, Jeff stamps 15% of the packages. So that would be 0.15. And of those 15%, he fails to stamp the expiration date once in every 90 packages. So F here is going to be 1/90. So S, which is that the package is stamped correctly, is going to be 1 minus that probability, 1/90, which is going to give us 0.9889. And then last but not least, we have Pat, where Pat stamps 5% of the packages. So that would be 0.05. And fails to stamp the expiration date once in every 200 packages. So here the F under the Pat would be 0.005 or 1/200. So S, that it's stamped correctly, would be 1 minus that probability, which is 0.995. All right, so now that so far, all we've done up to this point is just organize the information that we've been given, and we've been using our probability tree diagrams. Now let's go back to what we were actually asked. So here's the question stem. So if a customer complains that her package of film does not show the expiration date, so in other words, we're in this incorrect, that the package was stamped incorrectly, in other words, what is the probability that it is inspected by John? So in other words, we're interested in, so given that our package is stamped incorrectly, so what is the probability that it was stamped by John? So in other words, what is the probability of J given F? So that equals the probability of J intersect F divided by the probability of F. So in other words, the probability that the package was inspected by John and not stamped correctly. And then the divided by the probability that the package was stamped incorrectly or not stamped correctly. So here, let's just look at the probability of J intersect F. That's going to be the probability of J times the probability of F for J's situation. So here we have the probability that it was inspected by John was 0.2, and then the probability of that John had failed to stamp it correctly would be 0.005. So we're going to multiply those values together. And then we want to divide it by the probability that the package was stamped incorrectly. So we're going to add all of the situations that we have. So we have 0.2 for John times 0.005. And then we're going to add that to Tom's situation where we have 0.6. That's the chance that Tom had inspected the package times the probability that he failed to stamp it correctly. So that would be 0.6 times 0.01. And then the same for Jeff, which would be 0.015 times 0.011, and then plus Pat, the probability that Pat inspected it times this 0.005. So when you go and calculate all that math, you would get 0.001 divided by 0.008915, and that will give you 0.11217. And thank you, and that concludes this recitation video. Bye.